Welcome to my channel Fee Concepts CHM. This video is about heat engine, where we will see about the efficiency of an engine and the Carnot's ideal heat engine. Heat engine. Any practical machine which converts heat energy into mechanical energy is called as a heat engine. So the heat engines, they consist of a working substance which absorbs heat at a higher temperature. A part of that heat is converted into mechanical work and the rest of the energy is rejected at low temperature. So the working substance, different working substance are used in different engines. Like for example, in steam engines, water vapor is used. In gas engines, combustible mixture of gases are used. So the working substance, it goes through certain changes of pressure, volume and temperature, and then it returns back to the initial state. Complete changes through which the working substance undergoes from its initial state and back to its starting state constitutes one cycle of operation. Efficiency. The ratio of the mechanical work done by the engine in one cycle to the heat absorbed from high temperature source is called as efficiency of the engine. This is the formula for the efficiency. We denote it as eta. It is equal to Q1 minus Q2 upon Q1, where Q1 is the heat absorbed from source at high temperature. Q2 is the heat rejected to a sink at low temperature. So Q1 is the heat that is supplied to the engine. Q1 is the heat supplied to the engine. Out of this, some part of the heat is used and converted into work, which we denote as W, and the remaining part of the energy is rejected. It is rejected, we denote it as Q2. So from here we can find the work done. The work done can be found as Q1 minus Q2. So in the numerator we have this Q1 minus Q2. So we can substitute it as the work done. So we'll write it down as W upon Q1. Okay, where Q1 minus Q2 is the mechanical work done by the engine in one cycle. So this is another formula for finding the efficiency of the engine. Now this Q1 minus Q2 will be always less than Q1, so that the efficiency can never be 100%. The maximum value of eta is 1. In terms of percentage, it will be 100%, but normally we do not get eta is equal to 1 because always some amount of heat Q2 is lost. So the value, there will be always the value of eta will be always less than 1. So the efficiency of the engine can never be 100%. A 100% efficient engine is an ideal engine. Next we will see the Carnot's ideal heat engine. Now this is a theoretical engine and it has 4 parts. We will see the first part of the engine. It is called as a cylinder. So this is a cylinder. It has non-conducting walls. this double layer that you see. These are non-conducting walls, and the base is perfectly conducting. Then there is a piston, you can see a piston that is also non-conducting. It moves without friction. So it contains 1 mole of perfect gas as working substance. Second is the stand. The stand, it is a non-conducting platform normally used for the adiabatic processes where there is no exchange of heat between the working substance and the surroundings. Third is the source. Source can be considered as a reservoir which is maintained at a high temperature, which we denote as T1. So you can see that the top part of the source is conducting, so that in one of the process in the cycle, in one of the process, when we keep the cylinder on this source, so that heat can be transferred from the source to the cylinder. So the engine will draw heat from this source. Now it is assumed that the source has infinite thermal capacity. That is, any amount of heat you take out from it, its temperature remains constant at T1. Same way, there is a sink which is also a reservoir. The cylinder can be kept on this sink, and the working substance can reject heat to this sink. So again, it is a reservoir which is maintained at a constant lower temperature T2. So T2 is less than T1, and the engine can reject any amount of heat into it. So again, it is assumed that it has an infinite thermal capacity. You add any amount of heat to this sink, its temperature remains constant at T2. So this is the overall different parts of the heat engine. This is the cylinder, the source, the stand, and the sink. Thank you for watching this video.